This is a reminder that you should feel free to take as much time as you need to write all of the notes down and think about them. Pause the video at your own pace. Welcoming all math Martians here to section 4.3, equations and inequalities with absolute value. This is, let's give you a real quick absolute value refresher. If you are trying to take the absolute value of negative 5, that is actually equal to positive 5. That's because absolute values make everything positive when you're evaluating them. The absolute value of positive 5 is equal to 5. The absolute value is technically defined as the distance from 0, and both negative 5 and 5 are the same distance from 0. Now, one thing that doesn't mean, it doesn't mean that you can, I guess, what you might call distribute absolute values to terms. If you're taking the absolute value of x plus 3, that's not equal to the absolute value of x plus the absolute value of 3. Because you don't really know what x is going to be, if it's going to be negative or positive in the first place. It's just something you can't do, and something that often students try and forget to do, and they shouldn't. So the strategy is going to be absolute value, isolate the absolute value, and then split the equation into positive and negative parts. Here's what I mean. You're going to have the absolute value of x is equal to 5. If that's true, then you can really split it up into two different parts. You can split it up into x equals 5 or x equals negative 5. And those are, in fact, the two answers. If you try them in the original, they both work. Great. Let's try another one. If you're given an equation like this, absolute value of x minus 3 minus 1 is equal to 4. First, isolate the absolute value. We're going to move the 1 over to the other side by adding 1. You get 5. And then this absolute value, once it's isolated, you can split it into two parts. X minus 3 equals positive 5, or x minus 3 could equal negative 5. When you add 3 to both sides, you get 8, or you get something else here. I'd like you to finish the problem. Pause the video, and when you're done, you can move on. Example number 3. Solve and graph the absolute value of 3x plus 2 is less than 5. Well, here, because there's a less than symbol here, you can split it up into two different parts. We have 3x plus 2 is less than 5. All this is pretty much identical without the absolute value. But then also on the other side, you could say that this could be greater than negative 5. Negative 5 is less than 3x plus 2 is less than 5. As long as 3x plus 2 is in between positive 5 and negative 5, it'll satisfy this original condition. This is kind of a format that I find the easiest way to do is just to make sure you have memorized. And I'll summarize what that format looks like a little bit later. I'm going to subtract 2 from all three parts. We're going to get negative 7 is less than 3x is less than 3. And when you divide all three parts by 3, you get this. And that's a decimal, but that's fine. And then here, you can see we're on a number line. We have open dots because these are less than, not less than or equal to. And you shade everything that's inside, in the middle. You don't shade the outside parts because x is everything that's in between 1 and negative 2.3 repeating. This circle is at negative 2.3 repeating. Solve and graph absolute value of 5 minus 2x is greater than or equal to 1. I want you to just first of all compare and contrast. These are absolute values, and you have a number on either side, and this is less than, but this is going to be greater than. So let me show you what the format kind of looks like here, and then I'll generalize it with a rule at the very end. If we're solving this, we're not going to split it up like we did before. Instead, we're going to split up into two distinct parts. This is going to be, like a disjunction we saw from last class. And this is going to be pretty much identical without the absolute values. 5 minus 2x is greater than or equal to 1. Or 5 minus 2x is less than or equal to, you see how it got switched, negative 1. This is the opposite. So now we're going to solve these individually and plot both answers on the number line. Subtracting 5, you get this. Now here, seeing that we have negative out front, when you multiply or divide both sides of an inequality by a negative number, you have to flip the sign. So you see, because this is negative 2, I'm going to flip the sign. It starts out as greater than or equal to, and now it's less than or equal to. X is less than or equal to positive 2. So here, because it's less than or equal to, it's a closed dot, and then everything to the left is less than or equal to it. All this stuff. Over here, you're going to subtract 5 again. You divide by -2, flip the sign again, you're going to get 3. It's different. It's a different number because you start off with a different number. Anyway, x is greater than or equal to 3, and start here and shade everything on this side. So any of these numbers will work. As long as you have a number that's not in between 2 and 3, then when you take the absolute value of all of this, it'll be greater than or equal to 1. So let me show you kind of the two different cases that we're going to have. I want you to compare these. If you see something like this, x plus 1, the absolute value of x plus 1 is less than 3, for example, it's going to be an inequality that gets shaded like this, a conjunction. It'll be, it might be open dot or it might be closed dot, but anyway, you have two dots and you're shading in between. The exact opposite is true here. If it's greater than or equal to, then you're going to have these dots and shade to the outside. We'll talk more about that in class if you like. Here is how the textbook states it. So you can see here's the conjunction, here's the disjunction, and these are the conditions that you need. So without further ado, go ahead and get started on assignment 4C. Copy the problem list. Make sure my audio check, Gerald Ford, president, is there watching you. And then do the first problem, and I'll see you in class.